So Clojure has a number of different data types. So you have sort of the regular, you have an integer, uh, doubles, or floats, but I think they're called doubles here. Uh, you have, true, false, nil, kind of the typical stuff.
Data types.
You have strings.
Integer. Double. Oh. Oh, I see. True. False. Boolean. String. String. Keyword. Okay.
Okay, I'm just gonna put some stuff here and then do some explanating. Oh, yeah. This is actually a hash sign.
Hmm?
So I'm typing hash and then open curly brackets. But if I put them next to each other, then my Emacs just makes it look funny because I need to be fancy. So I'm really sorry for the confusion. Really should turn this off. Um, but I need to reboot my Emacs, I think, to turn it off. Uh,
Parentheses between square brackets.
okay.
Between brackets.
This is the most important stuff, I think. Now, this looks so. Most of them are simple because they are themselves, right? Like if I type 2 in a REPL, then that's 2. Or if I type a vector of a number of things, then that's that vector. But if I type a symbol, uh, then that's not itself, that points to something. And if I type a list,
Okay, I'm done. So, if you have time, see you. We need to make use of this. That Bettina's husband is not here.
yes, we shall.
Okay, see you guys.
Alright,
See
bye.
you.
So for all of these, if you type them in a REPL, you basically get the exact same thing back that you typed in, except for the list and the symbol.
Okay.
And so here we need to kind of talk for a minute about the two ways that you can look at Lisp code, at Clojure code. So when when you give Clojure some code, some expression, it's going to evaluate that in two steps.
Okay.
First, there's what is called the reader, and then the reader basically takes your text, your characters that you typed in, and it's going to turn that into structured data. So it's going to read it in, and it's going to read that as data. So when I pass it this list as text, the first step is going to be this reader thing, which has like, oh, that's a list, I know what that is, and then like internally, now Clojure has a list. But then in a second stage, Clojure is going to take that data that you that just got from the reader, and it's going to evaluate that.
That's why you need quotation marks. Why you need the symbol ticks.
Yes, this quote, yes. Um, so, and the way that Clojure does that, when you, so once it gets that data, to evaluate that data, the first thing, when you pass it the list, it's going to consider that um, depending on what's in the first position, it's going to try to execute that in a certain way. So the simplest thing is when the thing that's in the first position of the list, it's something that points to a function or resolves to a function. What do I mean by that? So we saw that with def, we can basically bind some value to a function, to a symbol. So foo, I made foo with the symbol foo resolve as 1, 2, 3, point to 1, 2, 3. I can also, I can make the symbol bar point to a function, which returns 5. So now bar is a function. And when I put this symbol that points to a function as the first thing in the list, then it's going to execute that function. It needs some arguments. So basically, this is how all functions in Clojure work. Like plus is a symbol, kind of like a variable you could think, which points to a function. And like we can ask for the source of a function. We can ask for the doc of a function. Or we can put it in the first position of the list, and then it'll be executed with the rest of the list as its arguments. So the first thing in the list can be something that resolves as a function. It can be the name of a macro, which we can talk about at some later date. Macros are sort of a whole chapter on themselves, but they're one of the power features of Lisp. Or it can be a special form. Now, a special form is basically these like handful of built-in things that kind of look like functions, but they do sort of special language stuff that you can't really implement on top of other stuff, like that kind of is sort of the foundational stuff. Like these are the special forms. So for instance, def would be a special form, I believe. Another special form would be quote. So quote is a special form which basically means that skip evaluating this piece of code. So we said that if I have a list, if I pass a list to Clojure, the first thing that's going to happen is it's going to take those characters, like the literal, open bracket, 1 space, 2 space, 3 close bracket. It's first going to read that, and then it's going to have that list. And then as a second step, it's going to evaluate that list based on what's on the first position. But if you basically want to tell Clojure, okay, here's a piece of code that, I want to read it so that it does that first stage of turning it into data, but then skip the second stage. Like, don't evaluate it. So when I do this, it's going to read it as data, but after that, it's going to try to evaluate it, and 1 is not a function, so it's gonna complain. And actually, it's once you kind of know what this means, it's pretty readable. It's saying, okay, a long, so a type of number, cannot be cast to a Clojure function. So I don't know how to turn this number into a function, basically. But if I use the special form quote, I'm basically saying, okay, everything inside here, read it so you get the data, but don't evaluate it. So now I get back the actual list.
Can we go back to this? The first position of the list should
Yes.
resolve to a function which can be a macro, a special form, and what was the first one you said?
So either it resolves to a function, to a macro, or to a special form.
But it could be a symbol or whatever that resolves, that
Yes.
points to another function. And I didn't get this thing with the apostrophe. When do you use that? When do you not?
Right, so for this, what I'm doing now, this quote,
Yeah.
there's basically a shorthand,
Oh.
which is this single quote.
Oh, right. It's a quote mark. Got it. Okay. I feel like whoever made this likes puns.
So this is really just syntactic sugar on top of this quote special form.
Okay, got it.
So to kind of so make this thing with like the function as the first argument, maybe like to give a different example. Say that I have this function that computes the sum of two things. So here fn is also a special form,
Okay.
right? It's a special form that creates a function object.
What's the difference between a special form and
And a function?
yeah?
They look kind of similar, but there's only a limited number of special forms, and these are kind of the foundation of the language.
Okay.
So these are kind of built-in things
Okay.
that all the rest is built on top of.
Okay.
It also means that they can do things that you can't do with sort of an ordinary function. Okay, so now I have this thing that, is a function. So when I put it in the first position of a list, then it gets executed. Do you understand what's going on there?
No, because I didn't follow what it did in the first one without the 5 and the 7.
Okay, so this just creates basically a function object. Right? It's like before I did the exact same thing.
Is this an anonymous function? Why do those?
It's an anonymous function. It's a lambda. So here I did the same thing. I used this fn to create an anonymous function with a single argument, and then I kind of assigned it to bar. And then afterwards I used bar
And you give me that.
to call this function, and it gives 5 because that's the result of the function. Now I can skip the bar and just do it in one go. So here I'm creating a function, but I'm not assigning it to anything. So like, the REPL tells me yes, okay, like this is a function object, but then it doesn't do anything with it. But then when I do the exact same thing, but like stick it as the first element in a list, so it's from here to here, and then there's two things coming after it in the list, then it calls the function.
I think I've seen this before.
So to play with that a little bit more, so like I said, actually there's a little graph here, right? So Clojure gets some text, ASCII or whatever, UTF-8 text, just plain text. Text goes into the reader. Reader produces data structures. Data structures go to the evaluator, which then evaluates it as code, and then you get a final value. So we can play with this. So here I have a string. Yeah. It's not a list yet. It's just a string, right? But inside it looks like a Clojure list.
I'm like 2 steps behind.
Okay. Where do we go back to?
Back to the anonymous function.
Okay.
My instinct is to put the double parentheses after the 7 and not after the second y. We put the second parentheses, or we close the first parentheses.
So this anonymous function starts here and ends here. It consists of 3 parts. Fn to say, okay, I'm making a function.
Yeah. My argument.
A vector, which are the arguments,
Uh-huh.
and then the function body,
What I want you to do.
what I want you to do.
Okay.
And so, I did the same thing here with the bar.
Okay.
Now I assign it to bar, and then I say bar, and then after the function, so I have bar in itself is a function. And to call it, I say, okay, put the function as the first argument, as the first thing in the list, and some argument as the last thing in the list.
Okay.
With the fn, I'm doing the exact same thing, basically. Saying, okay, this is my function. REPL says me, okay, yes, exactly, that looks like a function. You see this fn here, which is a hint. It's a bit cryptic, but okay. And now I'm building this list with the exact same thing. Like from here to here is my function.
Yeah.
That's the
Okay.
first thing in the list. And the other things in the list are the arguments that go to the function.
Yeah. Okay, I think I just need a little bit more time to think about it. Okay.
We can try this. So you would do it this way.
Well, I did.
Um,
Yeah, actually, I was doing some reading about this.
Yep. Cool.
Choose. Yeah, I read something about expressions and statements, and I have to say I'm not really sure what the difference is between the two. But let's just continue. I think that's, I don't know, that's something you want to get into.
Expressions and statements, I think in Clojure, it's not a huge distinction. Like basically everything is an expression. And like an expression can be just, a single number, or it can be something, or like, basically all of these things or any combination thereof that is sort of complete is an expression. By complete, I mean like, if you would have, this is not an expression because it's not like, it's only half an expression, right? Like it doesn't end.
Because there's no closing parentheses.
Like it's unbalanced. And so, yeah, the way that you look at Clojure code is from the inside to the outside. So, when I do this, where is it? Here. So, first this from here to here gets executed, and the result is a function. And then you go one level up, from here to here. Okay, call this function with these arguments.
Yeah, I think I just need some time to
Yeah, I think, just get some examples.
get into it. Okay.
Yeah, I don't know, this might make things more confusing, but think it's super interesting, like this read string and eval, because basically what I would like this here, you know, these two blue blocks you have available yourself.
I have available myself.
So one is called read string. So this takes some text and turns it into a Clojure data structure. Let's say that we have something that is actually valid code. So this would be the same as this quote 1, 2, right? Exact same results. Now we can eval this. So this is, here you kind of see the cool thing about Lisps. So in another language like Ruby and dynamic languages, you also have this eval, but it just works on strings. But in Clojure, this eval works on a data structure. Why is this awesome? Because this means that you can basically generate some data structure with code and then evaluate it as code. So you get this blurry line of what is code and what is data. So let's, as an example, say that I have
Okay, can I just go back to that statement? So we can evaluate and read data structures,
yes.
which is awesome. And here in your example, the data structure is actually a function.
So in this example, in this eval read string, like the results, so here this is just a string.
Okay.
Then if we go one level outside, we have a list
Yeah.
which contains a symbol and 2 numbers.
Okay.
And then when we evaluate that, then Clojure gets a list. What's the rule for a list? Okay, the first thing is a thing that will get evaluated, the rest will be arguments. The first thing needs to be a special form or something that points to a function or a macro. In this case it's a symbol. A symbol, we're gonna just see like what it's defined. In this case it's the symbol plus. Plus is defined as the addition function. So it's gonna take the addition function, pass it 1 and 2, evaluate that, you get 3. I'll give a few more examples.
Okay. I guess like maybe that's exactly your point. Data structure and code. Same.
Same.
But how do you use it in like a practical sense? Like what's the use of having coded data?
Well, I mean, the most obvious use is macros. I think it would be a lot to. Have you touched on macros before?
Just in Excel.
Actually, yeah, why the heck not? If we're this far anyway, let's talk about macros.
Let's go all the way in.
So a macro looks like a function, but it's a special function.
A macro is a special function. Huh. And a special form is a built-in function. Man.
Basically, so when I define a macro, yeah, let's give the name. Trying to think of an example that makes this clear. So basically, a macro is like, it's like a function, but instead of, so, okay, you have these 2 steps, right? You have the evaluator and you have the reader. A function is evaluated here a macro is evaluated here.
Uh-huh.
So what this basically means is a macro is a function that gets code as data and returns code as data, and then that's the final resulting code. So it can transform what you give it into what it needs to be. Um, so, but trying to think of an example that you wouldn't be able to do just with a function. Um, oh yeah, okay. Let's say infix. That's always a fun one. A operator B, and then oh yeah, one. Yeah, I'll have to explain one more thing. So yeah, we saw this way of like with quote that you can like just make a regular list, but you can also actually just put list as the first argument. Like it's basically a function which which takes the rest of its arguments and makes it into a list. So that way you can also get a list.
Can you use the quote in the macro as well? Or is there a reason you did?
There's a reason I'm doing this, because if I use the quote in the macro, then so basically, well, let's first see what this macro does. So normally you would say plus 1 2, but say that we want to write 1 plus 2, right? That doesn't work. But ta-da-da! With our magical infix function, or macro, I should say, it totally also doesn't work. Oh. It works. So how did it do this? So let me, it is totally metaprogramming, yeah. Let me make this infix, like basically define the same thing as a function. So you kind of see what happens if I say, infix fn 1 plus 2, what it returns is, well, yeah, it returns the plus function in a list as the first element of the list, and then 1 2. And this, in turn, you could eval, and it would be 3. So it's a list that comes out of it. The list contains 3 elements. The first is something that's a function.
Operator. Oh.
Yeah, the operator.
But is the macro equivalent to like the infix function and do an eval on it, or is it?
Well, it's not. It's conceptually it's kind of the same, but the macro executes at sort of compile time.
Oh yeah, right.
Oh, I was also reading about like runtime, compile time,
Yeah.
all
So
those different times, and I was like,
yeah. So I mean, Clojure, because it runs on the JVM, and the JVM executes Java bytecode. So it needs to somehow turn whatever you give it eventually into Java bytecode, and then say, okay, now execute this code. So actually what we saw here, it's not the whole story.
okay.
Basically you get like it's being read, you have the reader, turns it into a data structure, then it gets compiled, and only after it's been compiled can it be executed.
Evaluated. It's executed.
Evaluated, executed, yes.
Okay.
But conceptually this is correct.
Okay.
And so
And this all happens during runtime, or is runtime something different?
no, like the last step, the evaluating or the executing, is runtime. So this way you can sort of, certain costs that you only pay once, sort of during compilation, You can sort of, do stuff with your code that only needs to happen once, so that by the time it starts executing, it's already kind of in the state that you want it. So sometimes for efficiency, like macros can be good.
Are there things that you can only do with macros that you can't do? Okay, I'm trying to be lazy and thinking, oh, maybe I don't ever need to do things like this. Maybe I don't need ever to read and evaluate before
Yeah, so I
compiling.
mean, in this case, we could use we could define an infix function and use eval, but like that's cheating, and it's not the same thing because of the runtime compile time difference. So in this sense, like this infix is an example of something that you can only really do with a macro. Like it's basically, it changes the semantics of what's inside of it.
So macros change.
Like it's meta programming. It's like, you can.
Can we go back to what is really changing here? This infix?
Yeah, let's go back to here. What's actually happening here? So it's something that takes 3 arguments, a of b.
Are those arguments evaluated? Like is 1 plus 2 evaluated, or is like?
Good question. No, they are not. So really, when I call this as a macro, actually, macro x.
Yeah.
In a normal function, like 1 plus 2, like if that was any of those were a function, it would be like evaluated and the value would be passed into the function. So I was asking
If one was a function.
Yeah, so with macro expand, you can sort of see the result of what happens when you call a macro. And so when you call a function, say that actually let me compare these two. So this one and then our function version. So you see that if it's a function, then before it can call the function, it needs to have all its arguments. So it's gonna, look at this first argument. Oh, it's a list itself, so I need to evaluate it. So I need to call this plus, and that's gonna be 3. And then okay, this is just this plus function. I can pass that right in, but I'm gonna take what the symbol points to and like get the actual function and pass that in. And then it's gonna evaluate this and say, okay, that's 7, and it's gonna pass that in. So what our function gets is not a list, a symbol, and a list. It's a function and 2 numbers. But the macro gets the raw data, so to say. So it gets a list, a symbol, and a list. Does that make sense? Exactly. So, and that's also like some macros are actually important to do laziness. So there's in programming languages, people make a distinction between strict evaluation and lazy evaluation. And most languages that are strictly evaluated, which means that before you can call a function, you need to fully evaluate every argument. In a lazy language, these arguments can be passed in as complete expressions without yet being evaluated. And then it kind of depends on what the function does with them, if they get evaluated or not. Basically, if it needs them, then it needs to evaluate them, but otherwise it doesn't.
I can see how this could get messy over time.
Macros can definitely get messy. It's a well-known fact.
Oh, okay.
Yeah.
Say that again? Magic programming? Did you? Oh.
Yeah, definitely. Like you can do all kinds of funky stuff and not always the nicest. Yeah. Questions? Shall I just give a few more examples of hypothetical? Well, actually, yeah. Let's because at first I wanted to call this infix like this, right? And that didn't work. Like I basically wanted to take the code as I wanted to write it and have the macro transform it. So let's see how we. So in this case, our macro only takes a single argument, and we're gonna call it body. And so this now body is gonna be this list, and the list is gonna have three elements: number, symbol, number. And so now we need to get the three elements out. And the way you do that is, I think, would get. Let me see. Map key, transfer map to key. Oh no, that doesn't work with list. And lists. Okay. Yeah, so the macro, body, list, and then we say we want the end body 1 and body 0 and body 2. Nope. Unmatch the limiter. Open, 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 close, close. Looks fine to me. What am I doing wrong? Anybody sees where the...
I think you have an extra.
Oh, I'm not opening this one. Alright. So let's try again. Infix. Alright. And so here you see that you basically have the complete power of Clojure available. So we could also define this macro in a completely different way. So body is a list, and we could say map and body percent 102.
Wait, I'm actually not really quite sure what env does.
Okay, let's see if this one still works, and then because now we're getting into some more examples of other stuff that is just plain Clojure stuff. So first of all, end is just a function that returns the end thing of something. So it's a very generic function, so it has a very generic description.
Yeah, the description was,
So say that this has three elements. I can say, what's element 0, what's element 1, what's element 2, and now I will probably get a index out of bounds exception.
Okay.
It works with a vector. It also works with a list. It even works with a string. So that's map. The other thing that I used there, so we saw that with fn you can make a function. So I'm basically making a function that gets say that I'm getting the function that gets the end thing of this list. So that I can see, okay, what's element 0, what's element 1, what's element 2. This is
Yeah.
clear this time, like how that
Okay.
works with the...
Yeah.
There's a shorthand for defining functions, which looks like this. Actually, let me first show just the shorthand. So instead of putting this fn and then the arguments and then the actual body, you basically just take the body part, you know, so the one that starts here, and like, you know, you skip this first stuff, skip this last stuff, so it's basically like the actual invocation you want to do, but you will put a pound sign in front of it, a hash. And yeah, we don't have a list of arguments now. So for arguments, you just use these percent.
No matter how many you have.
Well, percent, actually it's like %1, %2, %3.
Okay.
And if there's only one, you just use percent.
So
For these type of functions, I don't think you can split. But in regular functions, you can do something like this, I think. Yeah. This is actually, so up to now we've only seen pretty simple stuff like, you know, basically like x, y, you know, a couple of arguments. But there's all kinds of stuff that you can do with these argument lists. Yeah, so it's basically called destructuring. Oh man, we're covering so much
wait,
ground
I'm
here.
I'm still at the hash thing. So a hash is also defining an anonymous function.
Yes, let's not do everything at the same time. It's just a shorthand. So
Okay.
this is completely equivalent to this. Yeah.
So it's basically say the hash is say anonymous function, then you put in the parentheses where it tells you what it should be doing.
Yeah, so basically, I mean, when you have like a short anonymous function that only does a single call, like in this case we're only doing end and we're not doing 2, 3 things in a row, then this pound hash thing might be the most succinct way of typing it. And then what was I doing with it before? Oh, here, this one. So then I'm using map. So when you look at the documentation for map, it takes a function and a collection, or a function and 2 collections, or a function and 3 collections. You get the gist, like a function and a number of collections. And yeah, then it's a bit of babble, but like returns a lazy sequence consisting of the result of applying f to the set of first items of each collection, followed by applying f to the set. Okay, so in simple speak, it's gonna call f with every argument in the list, and you know, like give you back a list with all the results. Then need it, yeah. So, for instance, say that I have a map. right? So here I just make an anonymous function that doubles something,
Mm-hmm.
and then I map it over 1, 2, 3, and we got 2, 4, 6.
It's so easy when you explain it, but I have trouble arriving on this on my own.
Yeah, try and practice, I
Okay.
guess.
Yeah.
Maybe we need to start giving exercises or.
Okay.
Um,
Okay. Thank you.
yeah, no worries. Thinking if actually I probably already explained way too much for one setting. Like we should have stopped half an hour ago and then given you a couple of exercises. Um, let's see. Yeah, I know.
Oh.
Yeah, I found this is like some Clojure course from some university in Dutch.
Yeah. First, I have to learn Dutch, and then I can do my homework.
No, that's I'll pick a few exercises and tell you what to do. Okay. Well, we haven't learned partial yet, but we know the other stuff. Uh, okay, let me change this to not have these funky characters
Why not?
because it's confusing.
But they're so cool.
Do I have internet? Yes. Okay, so these these two lines, don't type them in your REPL. Just think about it and tell me what the result is. Think it out first silent in your head so you each get a chance.
I'm done.
Yeah? You're still thinking?
I thought like if you have a minus, you already have to find this, but then you can redefine the line.
Sorry?
Like the anonymous function, the second line.
Yeah.
Um,
Okay, so how.
okay, now I get it. Yeah, it's fine.
Yeah, you got it?
Yeah.
Okay. So, how much do you have for the first one?
12.
And do you have for the second?
Same.
Yes.
Well, can I just ask?
Yes, you can always ask.
Based on my notes, I would expect that this percentage sign would be in the place where the 19 is. Did I make something up in my head?
So let me rewrite this as Well, actually, let's. So the percentage sign kind of goes together with the hash sign, right?
Yeah.
And so if we pull this thing apart, then this is the inside of it.
Mhm.
So this is an anomalous function minus first argument 7. So like first argument minus 7.
Yeah.
And then as argument we pass it 19.
Okay. So that the percentage sign just means argument.
It's a placeholder for what you call it with.
Placeholder for any argument.
Okay, this one's okay. Um, so define a function with signature x, y, others if only x and y are given. Function multiplies x and y. Otherwise, it adds x, y, and all of others together. To solve this, you're gonna need a couple more things. First, the if through, now it's true, now it's false. So that's basically just how an if works in Clojure. Now it's true. Now it's false. And then you're also gonna need empty with a question mark. And start just with the first part. If only x and y are given, it multiplies them. The second part is actually a bit complicated. Do you know how to get started? Okay.
Well, I think I know.
So say that your function is foo. So at the moment it should basically work like this. Yeah, I thought so. Thanks for coming over.
Yeah, no problem. Thanks for letting me know about it. It was cool.
What did you guys do this afternoon?
We did like the free walking tour, so just like did like a walk around the central Berlin area. So like checked out the like gates and like the Holocaust Memorial. Yeah, right.
guess
it's just
because
like
you thought about making me maybe
supposed to
turn
be
for
like
dinner or?
other objectives.
Yeah, that could be good.
Yeah.
Like not
If
literally
you like,
and
you're in a certain area, or you see something you like or something.
like
Or if you have
ABC.
any suggestions.
Yeah.
Like
Yeah, okay, I'll think about it.
they always have it.
Anything style?
Yeah, I
or-
know. I'm having trouble finding.
Well, I guess you'll be in the maybe, but yeah, we'll probably go back to the history first for dinner.
Maybe, yeah.
No.
Are you staying like the one right at Clojure? The
Yeah, the stay, no, the
Come back.
come backpackers.
Yeah.
Oh, okay.
Yeah.
Yeah.
There's like a supermarket and then kind of like a bunch of like little like small stores and stuff. So you get out and if you walk like northwest-ish, it's around there. There's like the bridge that says like Kreuzberg or like an underpass or something. And it's like you can look at it and you turn left and walk this way. It's like
Oh yeah, I think I know.
you guys might have it on maps.
The name rings a bell. I used to live around this area actually.
Yeah, it's right like right around there. It's in that area.
Yeah. Oh yeah, right. Yeah, okay, yeah, that's what I thought. Okay,
Yeah.
that was called differently. Hostel, something with a number. Yeah, cool. Actually, yeah, there's a couple places around here that I don't mind going again.
Sure.
Cool. You guys like Swiss food? There's yeah, they have really nice staff and really good Swiss place around here.
Yeah, sure.
Yeah.
That'd be cool.
Okay, yeah, totally. Okay, well then just let me know around what time. I'm probably working until at least 6, so the rest of the day's work.
7.
Yeah.
Okay.
Alright,
Cool.
sounds great.
Awesome.
Have a good night.
Yeah. See you tomorrow.
See ya. Sure. Yeah, you need a space between the ampersand and the
Can I really do it like that?
Ooh, no, that's not gonna work.
You want to look at somebody else's?
So, the second hint I gave you was this one.
Oh yeah. What's this? It checks if it's empty.
Yeah.
It's a boolean.
Yes.
Hey Anna, with the doors closed and the gate is closed, we have to walk back up, right?
Oh yeah,
I
shit.
should probably
I'll go.
Huh? No, it's fine. You sure? Yeah, it's not. Huh?
What does others look like?
Wait, I'm actually. Okay, that's also empty, so that would actually work. You're not following me, Tina.
No, I'm not.
So I just defined this function that has the same signature and just returns its arguments.
Uh-huh.
So this others is the splat argument, as you would call in Ruby. Like it collects all the extra arguments that you pass to it.
Okay.
So it's a collection. In this case, like it apparently it's a list.
Okay, I understand the first time you did it, and then when you ask for this, why does it give you a nil?
So when I say what does others look like 1, 2, and I don't give it others, then yeah, I kind of expected it would give me an empty list.
Okay, actually no, I take it back. Let's go back to your first thing. Where does the ampersand go?
What is the ampersand?
So you're saying my function, what does others look like, takes 4 arguments.
No, my function takes 2 or more arguments.
2, and the ampersand means or.
The ampersand means, so x, y are mandatory arguments,
Yeah.
and then I can add 0 or more arguments, and this will go into others. That's what splat means.
Not
now,
sure.
now you know.
Okay. And others.
So or yeah, variable arguments, I guess, is the generic term, var args.
Var variable number of arguments. Okay. Well then.
So that's why the question is like, distinguish these separate cases. Like you can just call it with 2, or you can call it with 3 or 4 or 5. And it needs to do something else in each case.
Can you go back to your other thing? Your terminal?
How do I expand bounds?
Ah. You mean like you want to call a function with those arguments again?
Yeah.
Then you need apply.
Okay.
Yeah, if you're already there, then you should be able to solve the other part of the exercise as well.
I'm trying to do that.
And yeah, apply takes a list, but before that it can take extra arguments. So when you look at the documentation, applies function after the argument list formed by prepending intervening arguments to args.
Because otherwise it takes X and Y and
Yeah.
both ways and then distance is better. But if you pass through arguments.
Indeed. So you're pretty much there?
Yeah, I've done it.
Awesome. Yeah, that's all it is. Okay, so let me help you along, right? So we're here, right? You want to define a function. Here's the signature, so the arguments. And then, okay, if only x and y are given, the function multiplies x and y. Yeah, so we're definitely going to need an if. You're good there. Now, how are we going to test if only x and y are given?
Well, I, I, I feel like I'm almost there, but not.
So you have x, y, and others. If you want to see if only x and y are given, it means that no others are given.
So you want to see that there's only two arguments.
Yeah, basically. But like, in this case, what's the easiest thing to check? Like, are we gonna look at x, at y, or at others?
I guess because you gave me this empty, I'm supposed to see if others is empty.
Exactly, but you're not sure why? Or?
Couldn't you say arguments, number of arguments equals 2?
I guess so. I don't know if we can Clojure
Count arguments? I have no idea.
number of arguments. I'm not sure if there's like a way to. I don't think there's like a thing you can call to say like, okay, what's the number of arguments? I mean, you could just like skip the x and y, you know, like and just call these arguments and say if count, I guess, arguments equals 2. That also works.
I think that was what I was kind of going for, but obviously not totally working out.
So that would be one option, but okay, like the idea here was to say
Use the empty, huh?
if empty others with x, y, and others.
If. So empty is a special
Empty is just a function.
empty. Okay.
So is others empty, basically. And then in the one case, you already had that, multiply x and y. And in the other case, well, add everything together. And so here, you know, you might start out with, okay, plus x, y, others. But then you can't really add a number, like sum a number with a list. So this is where this apply comes in. With apply, the last argument can be a list, and then it's gonna just add all those as arguments to the function.
Apply. What does apply do? I actually didn't get that from what was said here.
So apply takes f and args. And so it applies function f to the argument list
Okay.
formed by, so to the argument list args.
Depending.
Let's ignore this part for a little sec.
Okay.
So applies function f to the argument list args.
Okay.
It's basically, you know, calls f with these arguments.
Yeah.
But you see that it can also take several arguments. So 1, 2, 3, or more.
Yeah.
And so in this case, it's first gonna prepend those two args.
Adding it to the beginning.
Yeah. So I mean, this basically means that, you know, apply plus 1, 2, 3, 4, 5, 6 is the same thing as this.
Okay.
Right? Because it's like it's gonna prepend 1, 2, 3 to the list 4, 5, 6,
Okay.
and then apply the plus function with these arguments.
Does this is not very illustrative, but okay.
Let's see if this works. 45. Oh yeah. Already one step ahead.
So this is what this is all you have. That's why that's working, because it's got a
Shall we call
Call
it a night?
Yeah. I'm totally brain dead.
Yeah,